We already discussed carbohydrates. The main carbohydrate is what? Lactose, and we discussed the properties of lactose, physical, chemical properties, and so on. And we also discussed lipids. Total lipids content in milk is how many percent? 4%. Right. And then proteins, how many percent? 3.3. Include three groups. The main one is casein, the second one whey proteins, and a minor group MFGM proteins. And now we go to enzymes. Actually, enzyme belong to what group? Proteins. So it is okay if I call enzyme proteins? Yes or no? Yes, it is okay if I call proteins enzymes. Sometimes it's okay, but many times it's not. Enzymes are proteins which would have the capacity to catalyze biochemical reactions. So in milk, there are quite many enzymes, include the indigenous enzyme, exogenous enzyme. Indigenous enzyme mean the one that are naturally in milk. Exogenous mean the one that come from outside, especially from bacteria. Bacteria or microorganism, they need enzyme to work, okay, to digest the nutrient, to intake nutrient, and so on. And then when they contaminate into the food, they also bring with them a lot of enzymes. Okay. So with the respect to processing, mean when we do process to have dairy products, we need to pay attention on the enzymes which are produced by psychotrophic bacteria. Why we need to pay attention? The two groups, especially lipases and proteinases. Lipases are the enzyme which hydrolyze lipids, hydrolyze triglyceride. Proteinases are protein which hydrolyze protein. There are so many of them, but in dairy processing, we need to pay attention on the one which are produced by psychotrophic because they are very low battery. No, I mean they are very heat resistant. So it's difficult to inactivate the enzymes. For enzyme, when we do treatment, we use the word inactivate. But for microorganism, what words do we use? Destroy or kill. We don't use the word destroy or kill to proteins, but we use the word inactivate because enzyme are what? Components are not like living organisms, so we don't use the word kill like microorganisms. Anyway, these two groups of enzymes are heat stable and very difficult to inactivate during dairy processing, which may cause some issue or somewhere else. Third point, we genes of cheese. Some they are negative. For example, they cause lipolysis. What is lipolysis? One kind of fat rancidity. Okay. And at the third point, enzyme can be used as an indicator for heat treatment. Indicator means that we use enzyme to evaluate the heat treatment if it's okay or not okay. This case is good. Okay, we discussed this in chapter 6, also very nice, that how people use enzyme to know that if the treatment is sufficient or not sufficient. Some enzymes have antimicrobial effects. Can you give a name? You just met it a while ago. Lactoperoxidase. That is an enzyme which have antimicrobial property. And enzyme activity can also be used as a parameter to evaluate the quality of milk and dairy products. Good. Now, we just discussed several enzymes. Lactoperoxidase. Right, so we are talking about lactoperoxidase. This is, of course, an enzyme, is a protein, and this is in the whey protein that we discussed a while ago. Lactoperoxidase has antimicrobial properties because this enzyme can oxidize the thiocyanate into OSCN, and this one then inhibits a certain number of bacteria. The other well-known enzyme in milk is xanthine oxidase. Xanthine oxidase. This enzyme occurs in the MFGM. Okay, they stay in the MFGM, and this enzyme is also microbial. It can also inhibit a certain number of microorganisms. Why? Because this enzyme can reduce là khử, can reduce NO3 nitrate into nitrite NO2, and we already know that from the previous course in meat technology. This nitrite is very powerful to prevent Clostridia bacteria which produce spores, and Clostridia cause leg blowing of ripened cheese. In doing ripenings of cheese at the later stage, the last several months, for example, the spores of Clostridia may germinate into cells, and then they multiply, they grow, they produce some gas, and that gas may crack or break the structure of the cheese, and that is not good. And they call that late blowing, thổi khí trễ. And that is a defect in making cheese, and this enzyme can then reduce nitrate into prevent the late blowing. So in making cheese in the past, they use this one, this additive. They add this additive in milk. Okay, when we study chapter 7, we will know more. And then the enzyme catalase. This enzyme is actually, we already know before that this enzyme come with leukocyte, white blood cell. When milk has more catalase, higher activity of catalase, it will indicate that that milk is from metitis cow. Okay, the cow which have metitis, and then the milk have more leukocyte and have higher catalase activity. Lipases is the enzyme that hydrolyze lipid, that hydrolyze triglyceride. It will call the lipolytic rancidity. We have two kinds of rancidity, lipolytic and oxidative, and the enzyme will cause the lipolytic one. Phosphatase is also a well-known enzyme in milk, and this is used as an indicator for pasteurization. Indicator. We will see it in chapter 6. We'll see it again. And this enzyme associates with milk fat globin membrane, so stay in the membrane. A lot of that you just read somewhere here. Peroxidase, this is also an enzyme. This is also used as a indicator, but not for normal pasteurization, but for high pasteurization. Okay. For the pasteurization which is carried out at above 80 degrees C. Then we will see again this enzyme in chapter 6. Okay, so we are done with port enzymes. In this part, what do we need to know? We should know that enzyme in milk can be indigenous one, which means the ones that are in milk themselves, or can be exogenous, means they come from outside together with bacteria, right? And the second point, we need to know that there are many enzymes. The activity of enzyme can be negative, can be positive. Many cases this is negative, but in ripening cheese, for example, then this is positive. And then the third point we should know is that the lipases and proteinases from psychotrophic bacteria are very critical. That one we have to pay attention. Why? Because they are very heat resistant, very difficult to inactivate them. Okay. And the fourth point, we should know that several enzymes have antimicrobial properties. For example, lactoperoxidase, xanthin oxidase. These two have antimicrobial property. Lactoperoxidase is antimicrobial because they can what oxidize thiocyanate into thiocyanate oxide. Xanthin oxidase is antimicrobial because they can reduce nitrate into nitrite. Nitrite then prevent clottidia, which means we prevent the late blowing in ripening cheese. Several enzymes are used as the indicators for heat treatment. This we will see more in chapter 6.